So, are we alone in the universe? It's one of the biggest questions we can ask, right? And we usually point our telescopes out to the stars to find an answer. But what if the biggest hurdle in finding alien life isn't out there in the vastness of space, but right here, inside our own heads? Let's dive into how our own brains are both our greatest tool and maybe our biggest obstacle in this cosmic search. Or, maybe a familiar shape in the static of an old TV screen. That's not just your imagination going wild. It's actually a really deep-seated instinct, a mental shortcut that's been crucial for our survival. And as we're about to see, it has some pretty huge implications when we stop looking at the clouds and start looking at the cosmos. There's actually a name for this. It's called apophenia. It's basically our brain's automatic and often totally unconscious attempt to connect the dots and find meaning, even when there might not be any. And just to be clear, this isn't some kind of disorder. It's a completely normal human thing to do. So why do our brains do this? Well, it all comes down to survival. Think about it. Our ancestors had to be able to spot the pattern of a predator hiding in the tall grass, or figure out which plants were safe to eat. A really famous example of this is something called pareidolia. That's when you see faces in random objects, like a face in a piece of toast or on the front of a car. Our brains are just incredible pattern-finding machines, hardwired to create order out of chaos. Okay, so what happens when we take this incredibly powerful, pattern-seeking brain of ours and point it at the vast, mysterious, and often random expanse of the cosmos? Well, that's when things get really interesting. The universe, as you know, is just filled with unexplained stuff, perfect puzzles for our pattern-hungry minds. So let's take a look at a couple of famous examples where we've had to stop and ask, are we seeing a genuine signal, or are we just connecting random cosmic dots? First up, let's take a trip to our neighbor, Mars. For years, our rovers have been detecting whiffs of methane gas in its thin atmosphere. Now, here on Earth, almost all methane is produced by living things, everything from tiny microbes to, well, cows. But the methane on Mars isn't constant. It seems to come and go with the seasons, creating this really tantalizing pattern. And we've got the data to prove it. This chart from the Curiosity rover shows it pretty clearly. The background levels of methane almost triple from their lowest point to their highest, and it seems to peak in the late summer in the northern hemisphere. It's a strong, repeatable cycle, and that is exactly the kind of pattern that makes our brains light up with curiosity. So here's the million-dollar question. Are we seeing the seasonal breathing of tiny Martian microbes? Or are we just watching some weird, unknown geological process, maybe like gas seeping out from underground, that just happens to create a pattern that looks a lot like life? Honestly, scientists are still fiercely debating this one. All right, now let's journey way, way out from Mars to a distant star for an even stranger puzzle. Meet KIC 8462852, but it's way better known as Tabby's star. Back in 2015, astronomers were absolutely baffled by its bizarre behavior, these massive, totally irregular dips in its brightness. I mean, these dips were huge, sometimes blocking up to 20% of the star's light. A planet passing in front wouldn't even come close to explaining that, so naturally, our pattern-seeking minds jumped to a pretty fantastic idea: an alien megastructure, right? A huge technological project built around the star. But of course, science demands a more careful approach, and the leading natural explanation was a massive, clumpy cloud of dust. And this is a perfect example of the scientific process at work. When researchers looked closer, they found something really important. Different colors, or wavelengths, of light were being blocked by different amounts. A solid object, like some kind of megastructure, would block all light equally. But tiny dust particles, they block more blue and ultraviolet light than they do red and infrared light. And that's exactly what they saw. The evidence pointed overwhelmingly to dust, not a Dyson sphere. So this brings us right back to the core problem, doesn't it? If we are so prone to seeing patterns everywhere, and the universe is just chock full of weird and wonderful phenomena, how can we possibly search for a real signal from an intelligent civilization without just fooling ourselves? The answer is, you have to be rigorous. You need a dedicated, organized, scientific effort. And that is exactly where the search for extraterrestrial intelligence, or SETI, comes into the picture. So, what is SETI, really? Well, it's not about chasing UFOs or looking at blurry photos. It's a collection of serious scientific projects with one very clear goal: to find verifiable, unambiguous evidence of intelligence beyond Earth, usually by looking for technological signals. The classic SETI approach really is to listen. Scientists use these massive radio telescopes to scan different star systems, and they're hunting for a very specific kind of signal, something that's narrowband, repetitive, and complex in a way that nature just doesn't seem to produce. They're trying to find a clear, unmistakable sign of technology cutting through all that cosmic static. But, and this is a huge but, what if we're looking for the wrong thing entirely? What if our whole idea of technology is just hopelessly limited by our own, very human experience? Arthur C. Clarke famously said, "Any sufficiently advanced technology is indistinguishable from magic." And this just perfectly captures the problem, doesn't it? We're out here searching for something like our own radio technology, but a civilization that's maybe a million years ahead of us, they might be using something we can't even begin to imagine. Astrobiologist Paul Davies pushes this idea even further. He argues that our entire search is fundamentally based on ourselves. It's based on our physics, our ideas about communication. What if a truly advanced intelligence operates on principles of physics we haven't even discovered yet? Davies really challenges us to think bigger. I mean, what if advanced technology isn't even made of matter? What if it has no fixed shape, or it exists only as a subtle pattern woven into space-time? Or, and this one is maybe the most mind-bending of all, what if it's so advanced that to us it appears to be doing nothing at all? And this leaves us with a truly profound dilemma for SETI. How do you design an experiment to find something that our brains, and maybe even our current science, might be fundamentally incapable of ever recognizing as artificial? Now, it might seem like we're getting way ahead of ourselves here. But despite these massive challenges, scientists have actually thought very carefully about what to do if they do find a credible signal. Yeah, this isn't Hollywood. There's no single red phone that rings in the president's office. There is a real internationally agreed-upon set of guidelines. And the first steps aren't to shout it from the rooftops, but to verify it meticulously. Then tell other astronomers around the world so they can try to confirm it independently. To help with that verification process, scientists developed something called the Rio scale. It's basically a tool to rate any potential signal on a scale from 0 to 10. It combines factors like how credible the signal is and what its potential impact on humanity could be. This whole system is designed to make sure that any announcement would be based on rigorous, vetted science, not just wishful thinking or another case of cosmic apophenia. And so we kind of end up right back where we started. In this epic search for life beyond Earth, what's the real challenge? Is it just about finding that one tiny needle in a truly cosmic haystack? Or is it about overcoming the limits of our own minds to recognize a message we weren't even designed to understand? The answer, it seems, is still out there, just waiting to be discovered.